right, today we are talking about the array list type of object. So last unit we talked about arrays. This unit we're talking about a very similar but slightly different type of object called the array list. So, brief recap of what we talked about last unit. Arrays are a type of object in Java that allow us to store a sequence of values, and all of those values have to match in type. Once we have initialized the array, we cannot change the number of elements stored in that array. We can't add, we can't remove elements. We can change the values of each of the elements, but the size is immutable. It cannot be changed. So if I, for some reason, wanted to update or increase the number of elements in an array, we would need to make a new array. We would need to copy our values into that new array and then overwrite the original array. So let's say I have an array with 5 elements, and I want to make a new array where I let the user input how many elements they want. Hopefully they enter something more than 5, otherwise we'll run into an error here. But we're going to loop over all the values in mynums, the original array, copy those into the new size array, and then we're going to overwrite mynums with our new size array. So we're going to fully overwrite our mynums array with that updated size. Now, this works, but this is kind of inefficient, and this is fairly terrible. This is annoying to have to write, especially if we have to do this anytime we want to update the size. It's just not going to happen. So there's got to be a better way. And wow, of course there is. So today we're talking about a new data type that is able to change size. Very similar to an array, but the size is mutable. We're talking about array lists. So they're very similar because they hold sequences of values. All of them have to be the same type. But array lists, like I said, their sizes are mutable. You can add elements, you can remove elements from your array list. Unlike regular arrays, array lists are not directly included in Java. We need to import them from the java.util package. So we're going to import java.util.ArrayList, and that will give us access to that class, to that type of object. So we're importing our array list. Then we need to declare our array list variable. So it's very similar to declaring an array. We need to say what type of value we are planning to store in this array list. So if I want to make an array list storing strings, we would say array list, and then we're going to use these little arrow brackets. We're going to put our data type that we want to store in between those arrow brackets. And then we name our array list variable, just like anytime we name a variable. So that's our left side, that's our declaration. And on the right side, our initialization, we are going to call the array list constructor. And once again, we're going to specify the data type that's going to be stored. So we're going to use the new keyword because we're calling a constructor. We're going to say the array list type. Once again, those triangle brackets with our data type inside, and a set of parentheses because we're calling the constructor for the array list with holding strings. So it can be easy to forget those parentheses, but we do, in fact, need those in order to correctly call this constructor. Now, earlier in the year, we talked about wrapper classes and why they're even useful. And the answer is they're useful right now. We use them with array lists because array lists are only able to store objects. They cannot store primitive data types like int or double or char or boolean. And this is where those wrapper classes we talked about, such as integer and double with the capital first letters, come in handy because we can store int values in an array list of integers, and we can store double values in an array list of doubles because Java will automatically convert from the primitive to the reference type. But since ArrayList cannot store primitive types, we need to store an array list of the reference type variables. So we can make, or we can add primitive values to our array lists, but they need to be stored as the object type rather than the primitive type. So fortunately, Java does all of the handling on the back end for us. We don't have to worry about any of the actual conversion from int to integer or from double to capital D, double. Java handles all of it, but this is something we need to be aware of while we're working with array lists. Before I move on, is that all clear so far? That makes sense? Cool. All right. So calling the ArrayList constructor will create an empty ArrayList object. It'll have no values in it. It's possible to initialize them, but it's not nearly as easy as with regular arrays. So we're not going to cover it right now. We're just going to tend to skim over that. So we have that declaration and initialization line. Note, we don't need anything inside those parentheses. We don't need to say how many elements our array list is going to hold because that is completely changeable. We do not need to determine anything. So that is how we create an empty array list. Now, it is possible, we are allowed to create array lists without specifying what type of values they're going to hold. If we say array list, my array list, without the triangle brackets, saying what type of value they're going to store, this is allowed. But when we specify the type, when we actually have that there, it allows Java to find errors before we run our code, which makes debugging our programs much, much easier. So this is allowed, but not recommended. I'm going to strongly recommend anytime you make an array list, you use the, you define what type of values it's going to store, just so that it's clear to anyone reading your code exactly what type of values are going to be stored there. So some differences between array and array list. With regular arrays, they are declared and initialized in this way that we learned last unit. We've got our new keyword and then int or whatever type in square brackets with however many elements we want. Or we can initialize with a specific list, and that will create the array storing that sequence of values. Alternatively, not alternatively, those are our two options for array. Array list only has that one way to do it. We cannot replicate that second method. We cannot initialize our array list to be full of values already. We can only create them empty. However, arrays cannot change in size once they've been initialized, where array lists are completely flexible in their size. We can add elements, we can remove elements. Arrays can store primitive types or objects. So we have worked with both of these last unit. You can store an array of ints, or you can store an array of car objects. It really is completely up to you. Array lists can only store objects. However, the automatic processes within Java, autoboxing and unboxing, that kind of solves that problem. We don't really need to worry about it. So when we would want to use an array is when we have a data set that is not going to be changing in size or value very frequently. We would want to use an array list when our data is going to be changing in value or size with a high frequency, so that the ability to add or remove elements is useful to us. So now that we know how to actually create an array list, we're going to talk about a few things that we can do to add and remove elements. So we need to figure out how to actually put data into it. We're going to cover 6 different methods that we can call on array lists. Here's a beautiful table. The first one we are going to cover is the add method, and it has 2 different ways that we can call it. So first is the add method with a single parameter. It's going to return a Boolean, and the single parameter must be of the same type as the array list is storing. So if you're storing strings, your value has to be a string. If you're storing integers, your value has to be an integer. There you go. So this add method is going to put the value that you pass, going to add that value of object to the end of the array list that you call it on. So if I make an array list of integers called mynums, it's a new array list of integers. I can say mynums.add the value 4, and remember, this is a primitive value. I'm storing reference types, but Java will automatically convert from my primitive to my reference type without an issue. So mynums is going to now have the value 4 in it. Before it was completely empty, it had no values. If I call my add method multiple times after, they're each going to be added one after the other. So our array list is going to have the values 4, then 2, then 7, then 1 in that order. They're going to stay in the order that we put them into the array list. Now, the add method, it says it returns a Boolean. It always is going to return true, so it does not matter that it's returning something. Later, we're going to talk about methods where we will care about their return type or their return value. It does not matter what this add returns. If I want to have a value inserted at a specific index, I'm going to use the add method with 2 parameters. My first parameter is going to be the index that I want my value to be at, and then I need to give the actual value. So if we're working with that same array list, I can say mynums.add 1, 9. So my index is 1, my value is 9. So we're going to insert at index 1. So if we look at our indices 0, 1, 2, 3, we're going to add at index 1. So 9 is going to take this slot, and everything else is going to get shifted backwards. So this isn't going to change the value at index 1. It's going to put this value at that index and shift everything else back. This is going to increase the size of our array list. So once I call add 1, 9, our array list is going to look like this: 4, 9, 2, 7, 1. 9 will be at index 1. All the things that were at 1 or later are shifted back. Their index increases. Add makes sense. If you're familiar with Python, this is both the append and insert methods for a list. Cool? Cool. All right. Next, we are going to talk about the get method. The get method for an array list is going to be very similar to just accessing an array. It is going to tell us the value of the element at the given index. So I'm going to say my int val equals mynums, it's that same array list, dot get 2. I'm going to get the value at index 2. So if we look, index 2 stores the value 7. So we print val, we see the number 7. So we cannot access array lists in the same notation as we did regular arrays. We can't use the square brackets to say, I want at index whatever. We need to use the get method to retrieve that value. The size method is going to return the number of elements held within the array list. is very similar to the length value within a regular array. I could not tell you why the names are not the same. We have the size of an array list, we have the length of an array. And keep in mind, size is a method, just like for strings, when we use the length method, size is a method for array lists. So if my nums is the same as it has been, I say my nums.size, I'm going to see 1, 2, 3, 4 elements. If I add 1, 9, I'm going to insert 9 into that spot. Now my size is 5. I have 5 elements now. Now remember, just like anytime, our indexing starts at 0. So our largest index is going to be 1 bigger than the last index in our array list. Just like when we worked with arrays, just like when we worked with strings. The set method is going to allow us to change the value of an element in an array list. So in a normal array, we would say my array at index whatever equals a new value. Here, we're going to call the set method. So we're going to set at this index to this new value. So we're going to set index 1 to equal 9. This is not going to add a new value. It's just going to update the values currently held in the array list. Now, if we care about the value that was replaced, the set method will return that value. So if I print my nums.set 1, 9, I'm going to assign 9 to this position, and I'm going to print 2, because that is the value that was displaced when I did this assignment. So if we care about the value that we're replacing, we do have access to it when we call set. And our last method we're going to talk about is the remove method, which is going to remove from the index that you specify. So if I say my nums.remove 1, I'm going to remove the value from index 1. My array list is going to decrease in size. We have lost an element, so obviously our size is going to go down. And everything after that index is going to get shifted downward. So everything that was at 2 or higher is going to get shifted down by 1 index. And then similarly to our set method, remove is going to return the value that we remove. So if I call my nums.remove 1 and I print it, index 1 is that value 2. So when I remove it, it's going to return that value that we removed. So when we print it, we print the value 2. All right, I know I kind of blew through those. That all track. All right. So our differences between our arrays and array lists. We're going to talk about initialization. Getting a value out of an array. All we have to do is say our array and use a square brackets to say at index, whatever the index is. With an array list, we need to call the get method with our index. Very similarly with setting, we say array at the index equals some new value. With an array list, we're going to say array.set that at that index, we want that to have a new value. And then they have very slightly different ways to find out how many elements are in them. Now, those are all the places where we can do the same thing in an array list as we can in an array. However, array lists have more functionality than arrays do. Arrays cannot remove values, they cannot add values, and they don't have a method to check if they're empty. Where in an array list, I can call the remove method. I can call the add method with either 1 or 2 parameters to add a value. And there's a method to check if there are any elements. We can call the isEmpty method, and that will return true or false, depending on whether there are elements in my array list. All right. Any confusing things from this lesson? Any questions? All right.